Interactive air imaging technology. Interactive aerial imaging technology, also known as interactive aerial imaging technology, interactive holographic aerial imaging technology, etc., is a brand new display and interaction technology. This technology was first proposed by the research and development team of Anhui Dongchao Technology. The founding team of the company is all from the University of Science and Technology of China. This technology applies the principle of light field reconstruction, using a new type of material with negative refraction function, DCT plate. Based on the principle of light field reconstruction, the scattered light is recombined in the air to form an air screen. Combined with sensor technology, a real image is formed that does not require media support, and people can interact with the air screen. The characteristics of dielectric-free air imaging technology are: 1. Dielectric air imaging technology presents a real image that is projected into the air by an optical system to display the image of the device, which is a real existence rather than a phantom. 2. Dielectric air imaging technology does not need to be used in special brightness environments such as darkness, but can be used in bright indoor and outdoor environments. 3. The clarity of dielectric-free air imaging technology is close to 98% of that of display devices. 4. Dielectric air imaging technology can achieve real-time dynamic adjustment of imaging position and other functions. Air imaging technology has the function of constructing 3D suspended images in the air, which is more impactful in visual effects than holographic cabinets. The implementation of this effect mainly relies on the principle of light field reconstruction technology, allowing the light fields in the 3D scene to converge to the corresponding positions, thereby achieving a 3D effect. This technology allows stereoscopic images to be directly suspended in a free space outside the device without the use of any screen or medium. Viewers can directly view stereoscopic images with their naked eyes without wearing any auxiliary tools. Due to the high clarity and color fidelity of the images, the stereoscopic sense is strong, making them very realistic. It can provide viewers with novel and mysterious visual impact, stimulate their curiosity, and gather the popularity of the scene, the role of deepening the impression of visitors and enhancing the visibility of the displayed items. The mature mass production of this technology product has achieved scenario-based commercial applications in fields such as elevators, healthcare, public health, in-car displays, and smart home appliances. Taking the scene of a hospital operating room as an example, most hospitals are currently equipped with hardware screen display devices such as access control, computers, and query machines. The high-frequency use of bacteria, virus residues, and cross-infection risks has become a major industry pain point for operating room terminal equipment. The fundamental reason is that currently, the interaction form of the vast majority of operating room terminal screen display devices is extremely single, with only physical contact, which cannot avoid direct contact and operation by operating room personnel. The probability of SSI infection in patients caused by hand contact by medical staff is also high. Because of this, interactive aerial imaging technology has solved the hygiene blind spot in our operating room scene. Therefore, how to improve the interaction form of medical personnel while ensuring the stability and practicality of existing operating room screen display devices or contactable devices has become an urgent problem to be solved. The equivalent negative refractive index flat lens, DCT plate, product independently developed by Dongchao Technology is used. The flat lens is reconstructed through a special precision microstructure, using multiple rows and columns of rectangular optical waveguide arrays and peripheral triangular optical waveguides. It can directly create a real image of two-dimensional or three-dimensional light sources in the air to achieve true holographic images, achieving large field of view, large aperture, high resolution, and no distortion, realizing the characteristics of naked-eye 3D stereoscopic display without dispersion, structurally including a pair of glass windows with two optical surfaces and an optical waveguide component located between the two glass windows. Use infrared optical components such as airbar and real sense or depth maps to capture and analyze the user's gestures, and map the user's click position to the terminal interaction interface based on the action capture results, optimizing the user's operating experience. Including alternating infrared emitters and infrared receivers. The infrared emitter emits infrared light in a direction perpendicular to the module. The function of an infrared receiver is to handle the reception of infrared light in both left and right directions. The so-called left and right directions refer to only receiving or calculating specific angles of light in the left and right directions. The infrared emitter emits stable infrared light into the air, and when it is obstructed by a finger touching an object, it generates diffuse reflection. The diffuse reflected light is received by the infrared receiver at a certain angle, and the infrared receiver quantifies and grades the received light intensity signal. Depending on the position of the touched object, the received signal intensity also varies. By using the relationship between position and signal intensity mapping, the actual distance can be obtained. Innovation point 1. Imaging has no media and does not require a physical screen at all. It adopts globally leading interactive aerial imaging technology, and its core imaging technology is currently leading internationally. Currently, the only direct competitor is a Japanese company. 2. Operate contactless, non-contact screen display terminals, presenting the user interface of the terminal device in electronic imaging mode, directly imaging in the air. 3. Interactive sensitivity. After the project is completed, the overall product can achieve a millisecond level delay in operation, with stable and sensitive interaction, and simpler operation. 4. Using non-infection, users can control the interface image of aerial devices, achieving control over terminal devices. The entire process is carried out in the air without any physical contact process, completely eliminating the risk of bacterial and viral cross-infection caused by physical contact. 5. The system is stable and compatible, with absolute guarantee of device safety and stability, and seamlessly connected to the original system. Promotion and significance. Based on interactive aerial imaging technology, combined with screen display and interactive control technology, this project has the characteristics of non-contact, non-infection, scratch-free, static-free, dielectric-free, and interactive. Used in hospital outpatient and operating rooms, users do not need to directly contact the equipment, ensuring the hygiene and health of public places and surgical patients. Realizing contactless and interactive aerial operation without delay, especially outpatient self-service machines during the epidemic period, truly solves the potential risk of bacterial and viral cross-infection brought to users by physical contact during the use of terminal devices, effectively eliminating the person-object-person cross-infection mode. The research and application of interactive air imaging technology combines innovative visual experience and contactless new interactive features, providing new technological choices for innovative development in various industries, and will promote digital operations and new visual revolution in many fields.